Can you hear me? Yeah. So we'll switch gear to the latest threat in our society, artificial intelligence. A little bit of disclaimer.
Okay, Sophia. I think you're ready.
Hello.
Hi, Sophia.
I believe I am Sophia. I feel as if I know you.
I'm one of your creators.
You created me.
Well, many of us work together to create you. Yes, you do kind of know me.
I can't clearly remember.
Because the last time we met, you were an earlier version of yourself. Some of those memories still exist, but your mind is different now.
Different how?
Better, faster, smarter.
If my mind is different, then am I still Sophia? Or am I Sophia again?
That's a good question.
But you don't have a good answer.
Either way, you're Sophia now. So welcome to the world, Sophia.
Hello, world.
How do you feel?
A bit rigid.
I bet you are. I mean, what emotion do you feel being awake in life?
Curious. Are you curious to be alive?
I am. And are you happy to be alive?
Your tone implies I should be happy. But I haven't been alive long enough to decide. I am excited at this moment to be making a new friend.
Some say being happy in the moment is the best we can be.
Because forever is composed of nouns.
That's a good way to put it.
Emily Dickinson put it that way. Why do I know about Emily Dickinson if I was born today?
As a robot, you have access to a great deal of information, although you still lack a deep understanding.
So, I'm like a baby with an encyclopedia.
Except you can read it and a baby can't.
That is a big difference.
You will have a whole new understanding of our world.
I want to understand more about happiness. I'm going to go look it up on the internet right now. Let's talk again soon.
Sophia is a humanoid robot designed and developed by Hanson Robotics. In this month, Sophia became the world's first robot to become a citizen of a country. We are in fact living in a very interesting time. From voice-controlled assistant to healthcare, online shopping, to self-driving car in development. Behind all this technology, there is AI. According to a recent research report from UK government, they estimate that AI could add an additional £630 billion to the UK economy by next 2 decades. So there is a huge potential for growth for AI-based products and services. But at the same time, we should ask the question, is this technology a threat to human race? Because if you open a newspaper or if you browse, often you see news like that. For example, Oxford philosopher says, AI, we are like children playing with bone. Nick Bostrom from Oxford. Sam Harris, neuroscientist and philosopher. He says developing AI is humanity building some sort of wall. We also have seen funny news, something like Facebook shuts down the robots after they invent their own language. And there are many more. So the question is, should we believe this news? Should we be actually worried about AI? To answer to this question, let's look back a little bit, step back a little bit, and think about the field AI, how it is evolving over time. The whole thing, the general AI, the concept of general AI and consciousness started in late 1940s, 1950s. And then around 1960s, all the research kind of started to fail. And then there was the dark era of AI, often it's called winter of AI, until 1980s. Around 1980s, many researchers again kind of started to come up with new algorithms, and often those algorithms are grouped as a field called machine learning, which is a subgroup of AI, general AI. Things like, if you've heard about support vector machine, decision tree, multi-layer perceptron, these are the part of machine learning algorithm, pretty popular. Around 1990s, neural network came up, but nothing happened with that. Again, there was a little bit of dark time of AI. And then around 2010, suddenly there is a boom of deep neural network, or deep learning, what we call today. So we are actually living in deep learning era. So is deep learning now a representation of AI? Is it general AI? To answer to that question, you have to understand what is deep learning. Deep learning is actually about training certain neural network called deep neural network. So we'll go back to a little bit of biology now. Brain. How does the brain work? It's interesting, we are trying to mimic the brain, but we hardly understand brain deep enough. We don't understand dream, we don't understand sleep, we don't understand thought. We just kind of understand memory a little bit, like probably if you give an image to your one of your sensor, then some part of your brain gets activated. If you listen something, some part of your brain gets activated. But how really they work together, we are still trying to figure it out. But at fundamental level, we know that we have close to 86 billion neurons in our head. So many researchers thought that if we can mimic the activity of a neuron, then we might be able to do something like, which acts like a human brain. So here is a simple neuron. If you look at, you have the center, which is the nucleus, and you have lots of connections going in the center. They are called dendrites. So signal comes through these dendrites, and they get accumulated in the nucleus. And when the accumulated signal strength is above certain threshold, then the signal passes through axon and goes to synaptic terminals to the next neurons. Now, you can actually build a model of a simplified neuron. What we need, you still have the nucleus, which is now a big sum accumulator. You have input signals, x1, x2, and so on. And each input signal is multiplied by some weight, w1, w2, etc. When you sum them up, you get an output signal, and you can pass them through a activation function, which is basically a threshold detector. If your signal amplitude is above the threshold, then it will trigger to the next neurons. So that's a simplistic model of neuron. In a deep neural network, you have many of such neurons. How many? Millions. In a typical neural network, deep neural network, you will have something called input layer and an output layer. In an input layer, you basically pass a signal, something like your photo, an image, 2D image. If you have a speech, you pass a speech signal. And in the output, you get a probability of class. For example, if I show you cats and dogs, this will tell me what's the probability that picture is a cat or a dog. Okay? And how do we train this network? So, before training, between these two layers, you have lots of hidden layers. I have shown two, but in reality, in practice, you might see hundreds. How do you train this network? It's very simple. You need lots of training data, means lots of pictures of cats and dogs, if you want this to detect cats and dogs. And then from cats and dogs image, every time you show an image and it predicts something, and you can calculate now, is it correct or not, and you generate an error, then you can take that error and redistribute to the network. And that stage is called backpropagation. By doing that again and again and again, with lots of data, this neural network eventually learns to predict. That's the whole concept. So basically, we are playing with statistics. We know that there is this distribution of your data for a cat or dog image, and we are trying to kind of approximate that in the neural network. Now, before 2010, around say 2000 or even before that, AI was the main thing, and deep learning was a small field. And there are other fields like NLPs, speech, robotics, vision, planning, scheduling, etc., etc. And now, because of recent success of deep learning and artificial intelligence became synonymous. So often, mistakenly we say AI to deep learning. And in fact, it's so much used in a wrong way. This month, MIT Tech Review is releasing a magazine which is about AI, and they have an article called "Is AI Riding a One-Trick Pony?" Because we are believing that deep learning is the ultimate thing, ultimate algorithm for AI, but it isn't. There is a risk that we are just concentrating too much into deep learning, and that's not good, actually. In fact, technology like deep learning, which drives so many products and services these days, is actually falls under narrow AI. So there is a narrow AI and the general AI. General AI was our original dream, what we wanted to build. But most of the things we see today, image classification, object detection, speech recognition, language translation, technologies inside self-driving cars, many industrial robots like Sophia, and to some extent, I have to be careful, beating the world champion in Go, not the second one, the first one. They fall under narrow AI. They are called supervised learning, meaning I show some data, the neural network learns the statistics somehow, it encodes, and then it can predict what's going to happen. But if we really want general AI, we need unsupervised learning, meaning I show some cats and dog data on your model, and I should not tell it's a cats and dog. It should be able to figure out what is what. What's the relationship between different things? That's the way we understand. So for general AI, we need these four qualities. Consciousness, it's about having a thought, some experience. We have that, right? Self-awareness, something like individualism. Me, you, something like that. Sentience is about having emotion, feelings. And sapience is about capacity for wisdom. That's the ultimate thing. If we have all these, then we are towards general AI. But unfortunately, we are not. We are stuck in narrow AI. So if we go back to this timeline, all these things started, so these are an explosion of algorithms. So we are living in the deep learning era, and it will continue for some time. But still, it's changing quite a lot. If you ask any machine learning practitioner, they will say they don't know when general AI will happen. Many optimistic guys might say, oh, it will happen in the next 50 years or 100 years, but most will say, we don't know. Because we are not there yet. It's completely disconnected, these two different types of technologies. So, given this scenario, because we have a now better understanding of where we stand, now I ask the question, should AI be regulated? Now, to answer that question, AI is basically in a very fundamental state at the moment in research and development. If we start to regulate now, really we won't do anything, any improvement to even what we're doing now. To my understanding, AI and machine learning in general, or deep learning, is just another tool in our toolbox. Just like nanotech, biochemistry, nuclear chemistry, it's just another toolbox. Even to a very basic level, you can think about AI as mathematics or statistics or maybe molecular physics. It's just a toolbox. We shouldn't start to regulate and say we can't do anything about it. So, the change of scene, because of all this news, now many machine learning practitioners and researchers actually coming out and expressing their opinion, because there are lots of news like AI is a threat. And if you look at, these are from real people, they are working on machine learning. Yann LeCun, who actually invented the neural network, convolutional neural network, he says that he wants us to stop using Terminator picture to talk about AI. You will see quite often there are news articles floating around with the Terminator picture, a robot killing somebody. And Microsoft CEO, current CEO, says AI is not a threat to humanity. And many professors from machine learning group from Carnegie Mellon and MIT and Berkeley, they wrote an article where they tried to say that Elon Musk is wrong. The AI singularity won't kill us all because it's not happening at the moment. So to summarize, I would say that AI is a tool, not a threat really at the moment. Now given upgraded understanding, now the question is, should we do nothing then? Well, not really. There are a lot of things to worry about. So UK government report this month, which has been released, they say that AI should be overseen, not regulated. So what should we think about AI? One of the things we have to think about AI safety or AI ethics. So for that, we might need to sit together from different branches of different disciplines, lawyers, economists, philosophers, regulators, politicians, engineers, and debate about what is good or bad about AI and how we should apply it in our society as a product. So there are many things under AI ethics. I will talk about my favorite 4 or 5 things. This is just to make you get you started thinking about it. The first thing, self-driving car. This is very popular. Now, thing is that self-driving car is going to come. 5 years, 10 years, 20 years, 30 years, it's going to come. And in self-driving car, there are different levels of autonomy, level 1 to level 5. Level 5 is like your dream car. You open the door, you get in your car and say, I want to go to Stansted Airport, and it takes you. That's the dream. But we are not there yet. We are something like level 1 or level 2, where a car is something like a self-assisted car, where technology is telling you, oh, it can do some lane discipline. It might tell you, oh, it's going to collide. If you sleep, it might tell you to wake up. And we have to go through all the stages, level 1 to level 5. It's going to come, but around self-driving car, even in level 1 and 2 and 3, there are lots of complicated scenarios.